Thank you, Jessamine. Hello, everybody. Good evening. Thank you all so much for being here. So my name's Rachel, as you've heard. I'm not a comedian. I'm a mathematician. And so I kind of feel like I should explain a little bit what I'm doing here and how this happened. So what happened was Jessamine sent me an email saying, Rachel, do you want to be in Bright Club? I said, I didn't say anything. It was an email. I said, internally, I said, no, I do not. I'm not a comedian. Stand-up comedy is not a thing that I can do. So I got ready to reply. But there was this little voice that kind of said, oh, you don't have to reply immediately. You can reply later. So, okay, other things to do. Next morning, reply to Jessamine, no thanks. Little voice, wait a minute. And so this went on for quite a few days, and I sent an email saying, sorry, I haven't replied yet, and the voice kept going, and the voice was starting to get quite annoying. Like it said, other people who you know have done this, and they're not comedians either. Like, go away, voice, you're annoying me. And I kept going like this, and I sent another apology that I haven't replied, and the voice said, you expect your students to step out of their comfort zone, and you won't do it when you have a chance. Like, okay, voice, stop it. Then the voice replied to the goddamn email, and like, here we are. So there, don't. So, and I'm kind of realizing that this is not a victimless thing because everyone's here. But I couldn't think about that because I had to think of something to do for 8 minutes that would be about mathematics and that would be funny. So I racked my brains, and I kept racking my brains, and I got an idea. I know what I'll do. I'll get some props. I'll do some arts and craft here at Bright Club. And if I have some props to distract everyone, they won't notice that I don't have any jokes. So I did. I went to the discount shop where I live, and you can buy anything there, like for €2. And I bought 2 posters about mathematics, which was really great. I was very lucky. I have them here. You're going to see them shortly. And I was delighted with this, so I got to work. And about mathematics, that's kind of what I do all day. I was thinking that mathematics, as we all know, is useful for modeling things that exist in the real world that we want to understand and that we want to make predictions about or observations about or understand better. But also, the real world is a model, or at least a starting point, for mathematics. Because the objects of mathematics often come from the real world, but they don't really live in the real world. And so, for example, if you want to think about something like a very ordinary problem that we might all face, which is a mathematical problem, we have some people coming to our house for dinner, and we want to prepare the table. And so what do? We want to get it right, so we take the people who are coming and we match them up with the things that are in an imaginary list that was invented by humans that lives in our head. It goes 1, 2, 3. These things are just imaginary, like they're completely abstract. This is as abstract as you can be. And then we take the imaginary things and we match them up to the seats at our table. And then we know that everything would be okay. But these things, these invented things that are invented independently in lots of different civilizations in the world, they don't exist at all. They only exist in our minds. But then you realize that they actually have a life of their own, and they have behavior, and they can be added together, and they can be multiplied. And you can discover patterns within them by looking for them. And they suddenly, like, you're not in Kansas anymore, but also your table is not ready for the people coming. But you're you're in this world where things are, these creatures exist in your mind, and they're doing stuff. And you can be kind of like a mathematical anthropologist, observing the behavior of these mathematical objects. And you don't have to, you don't have to have a question that had lots of wrong answers and only one right answer. You can just explore, and you can discover nice things. So other examples of mathematical objects besides numbers are shapes like squares and hexagons and so on. And squares are beautiful things, and you can tile the floor with squares, and you can build cubes out of squares, and they like to be built into cubes. Hexagons are also very nice, and you can tile the floor with hexagons as well. So this is a bit small and far away, but who knows what it is? It's a model of a pentagon. The real pentagon lives in your mind, but this is a model of a pentagon. And pentagons are really, really beautiful things. That you can't tile the floor of pentagons because the angles are wrong, but you can do lots of other things. You can build a dodecahedron, which is like a pentagon version of a cube. You can't do that with hexagons. You can study the distances within the pentagon, like the diagonals and the sides, and you can discover that it's connected to lots of beautiful things, like the Fibonacci sequence and the golden ratio. And so I have some more pentagons for us to play with. So let me see. Yeah. So here I have some more pentagons. This is actually like a strip of pentagons, and it's made out of the mathematical posters that I mentioned earlier. So So there's one poster here which has all the numbers from 1 to 100. That's really nice. There's another one which has examples of things that can be counted, like 10 cakes and 7 spiders and 14 ice creams. So that's really, really very nice. So this is the this is a live performance art part of the act. So it's high risk. There's a high potential for things to go wrong, and I do recommend trying it at home though. And this is also the audience participation part of the act. So I would really like it if I could have a volunteer from the audience, like Kushik, who could come here and help me for a minute. So what we're going to do is we're going to find out what strips of pentagons like to do. So Kushik, what I need you to do, thank you very much, is to just this has high potential for problems. Let's try it. So I need you to just hold those two there. Thank you very much. Hold this one if you can. Thank you very much. And we are going to just take these two strips of pentagons, just kind of like, and we're going to kind of braid them around each other. We're going to just like wind them. Will this work? Yeah. Not exactly. Yeah, this is the risk with live performance. Yeah, kind of working. So look at that. I don't know how well you can see it. They form this kind of like this sort of tiling thing. They kind of group together here into little kind of pairs, and they make. Yeah, it's not really quite working. Hold on, we try again. That looks better. So see, you get this kind of tiling effect, and you can make more of these things, and you can tape them together, or you can weave them together to discover that pentagons don't tile the floor, but they do tile this like ripply, very cool surface, which is also related to other important things in mathematics. So the next step here. Thank you very much, Kushik. So the sort of next steps in this are for the not for the mathematics comedy night, but for the mathematics art and craft night, and I am completely here for that when it happens. Okay, so pentagons, fun things you can explore, you can create things, you can have fun, you can discover things that are of interest to mathematicians. So if I have a minute left, do I have a minute left? Just a couple of comments. This is the serious part of the talk. Right? So mathematics, I would say, is like theatre and comedy and music and drama and art. It has the ability to broaden and enhance and also challenge our views of the world around us and how we live in it. And it also, like theatre and music and art, has the ability to lift us out of that world and out of all the pressures and noise of our everyday lives and bring us on a flight of imagination, where our creativity is embraced and we have a sort of playground for our imagination there. And I know that many people experience mathematics and spend a lot of time in their lives working on it in the education system and elsewhere, and kind of don't get the chance to recognize that, and much less to experience it. And I think that's kind of it makes me sad, and I think what attracts people into mathematics and keeps them there is the enjoyment of this imaginative and creative aspect that that isn't always that easily visible. And so I was thinking that perceptions can change. And just another example from my life of that, which it reminds me of, is the other thing, besides mathematics and besides being a human being, the other thing that I've tried to learn to kind of be competent at in my life is the sport of rowing, which was my sport when I was a student. And I was a student for quite a long time. So, and then I was a rower. And rowing was regarded as very serious, very competitive, with a really kind of rigorous training regime. And you had to commit to all of that if you wanted to be a rower. And it wasn't, you weren't really supposed to admit to enjoying it, because then you might not be taking it seriously enough. And so, as everyone knows, Ireland is currently enjoying a really kind of good time in rowing and lots of interest in it. And a part of that is due to the success of the Skibbereen Rowing Club, and in particular, Paul O'Donovan and Gary O'Donovan, and subsequently Fintan McCarthy and many other people from all over the country. So Ireland won 4 medals at the World Championships just last month, including one from Katie O'Brien in Galway. So I think something that happened in rowing, which really kind of promoted interest in the sport, was that when the O'Donovan brothers won their silver medal in Rio at the Olympics, they got out of their boat after the race, and the serious sports analysts came along to interview them, and they said lots of things. But one of the things they said was, so does this moment, this great day, does it really kind of, does it justify all the hard work and all the difficult times and all the long days of training and everything. And they said, this sport is brilliant. We love doing it. And it was just to hear that. That is the energy that we need in mathematics. We love doing it. Thank you, everybody.